Hello everyone and welcome back. This is week 6 of module 2. We'll keep working hard on our house construction project and we'll do it in a way that I can show you a bunch of tips and tricks to optimize and solve most common problems we can face. As you can see, I had version up this scene now and I'm working on 002, but we still have the same settings and the same nodes we had before. And also this week we are not gonna create new folders, since everything we need is located in this week 5 folder, like the geo, the cache, and so on. First, I will start by showing you a very cool technique to art direct our interior detail. And although we are dealing with it as a hybrid geo, it doesn't mean that cannot be optimized. The main idea is to art direct our interior detail based on the area where the collision is taking place. So let's quickly dive inside this Zoom network. And what I'm going to do is to import our sphere, and I'm going to transfer the some attribute to drive this this fracture. So let's object merge our ball, which is here. Let's set an attribute to it. I'm going to call it density, value of 1, and let's transfer this to this geometry. Density, here we go. Let's visualize this attribute. And of course, we have to lower down the threshold. Let me see. Something like this. Okay, I like it. So I want this attribute transfer operation to be persistent. So what I need now is a solver sub. So let's plug the first input to the unpacked geometry. Remember, this has to be unpacked. And let's plug the second input to the collision object. So I will just cut and paste this into the inside of this solver and plug the first input to the previous frame and the second one to the second input. So now we should get persistent changes. What I'll do now is to add a time shift here. I'm gonna set this to $f_end to make sure we are taking all the possible collisions. This is done, so let's start with the wall. Let's go to the wall. I'm gonna cancel this cooking. Let's go here. And the first thing I'm gonna do is to optimize our remesh. If I open the Houdini documentation of this node, you will find under the attribute section this target mesh size attribute. And this attribute is used by the remesh node to drive the remesher. So it means that I can use this attribute to add more or less remesh to the geometry. So as you guess, I'm going to use the density to attribute. But first, and I know this because I made this mistake many times, be sure you are not using values of 0 or close to 0, because it can freeze your computer. So let's start by fitting our density attribute, and at the same time I'm going to create this target mesh size. So let's fit the density, it goes from 0 to 1, and let's create new min and max channels. to have the control of this with these sliders. Let's set this to 0.5 and 1 to start with. And if I go here, I have to change this tab to adaptive. Now I can play with these sliders, and you can see the remesh is being you can drive this remesh using the density. So let's set this minimum value to 1, and what I want to give it a low value is this maximum value. So let's give it a 0.02, and this should be fine. Let's do the same with the BDV from polygons. So instead of using this option, let's turn off this and let's create BDVs based on this density attribute. So this is gonna take the positive values of this density attribute and make volume from it. So now if I scatter points, I can play with the frequency again, and let's see what we get. Let's explode with this, and here we go. We have control on the regions, the areas where we want to have more detail, more small pieces. So this first step is great, but what if I want to add interior detail only in this impact area? What we are going to do is to set a new group using the inside wall group, which is this one, and the density attribute. And along with this, you're about to learn how to use the compact form of setting a conditional and how to create groups with vex. So let's drop down a primitive wrangle, because remember this inside group is made of primitives, and I'm gonna write this. All right, but first let's copy and paste this expression, because I just want to apply this statement to this group, which is the interior primitives. And let's say float density, and as you know, this is calling the density attribute we already have, is bigger than some value I have to set. And now I'm gonna add a question mark, and this question mark means, is density bigger than this value? If so, do create my group, and I have to type I group underscore. This is the way that Vex understands that you want to create a group, not an attribute. So after the underscore, you set the name of this group, which is going to be a primitive group. So let's say I want this group to be called interior detail and equals to 1. So now if this condition is true, I'm going to create this group and set it to 1. Now I'm going to type 2 points, and this means otherwise, or in Vex expression this is the same as if I type else. So let's set the otherwise value, which is 0. Let's close this with semicolon. Let me check if we created this group. We created this group, but as you can see, something's wrong. And this is because we hadn't promoted the density attribute, which is a point attribute. So we have to promote it to primitives. Let's do so with an attribute promote to point, from point to primitive, and then set the density. As I go back here, I promoted this density attribute, and now I have polygons inside this group. So now let's go back to the RBD interior detail, and I'm gonna delete this, and instead I'm gonna type interior detail group. Let's check if this is working. Of course, we have to set some value here. So at first, what we if the value is 0, you're seeing the same result as we had before. This interior detail being applied to every site inside group. So let me lower this detail size. So we can see, we can compare this more accurately. And now if I middle click here, I can see we have 640, 100,000 points. What if I set this to 0.5? As you can see, the interior detail of these inactive pieces, these pieces far from the impact area, has disappeared. And by doing so, we have less than a half of points. So this is super useful if we want to go crazy with the resolution. And remember to delete anything you are not going to use to be clean, to stay clean. So I'm going to delete the density, and I'm going to delete this detail group. Now, I would like to add more elements to the simulation, but let's first spend some minutes improving the workflow we have so far. I'm going to show you something, and I want you guys to take a look at this this help here. So let's jump to the object level and be aware what happens when I select the top network. As you can see, this is computing the convex decomposition of each element I have, and then I have to wait until the mix constraints are computed again. So as you can imagine, this is not a proper workflow to do this, because anytime I do a change, I have to do this. I have to wait until this is done. So let's improve this. Let's go back to the how geo. And I'm going to start with the wall as usual. So let's dive inside. And I want this convex decomposition to happen inside this subnetwork. Because every time we have to compute this node to have the proxy geo, I have to wait until the RBD interior detail is on. So let's get rid of this by taking the geometry, the proxy geometry from this output, which, as you can see at the bottom of this network, says proxy geometry. And if I visualize this, what I'm getting is the exact geometry is coming from the first input, this one. So this geometry has way less points than the one with the interior detail. So let's just convex decomposition this. Sometimes if you want to get rid of this representation, you can lower the max concavity. So let's just display this. I'm going to play the composition and see if I have any improvement. Let's set this to 0.5. And here we go. I will leave it as 0.4. I don't need the segment attribute. And let's go ahead and assemble this. Of course, remember to not override the name attribute, but just to pack this geometry. And I'm gonna delete. No, actually, I'm gonna take this output and plug it here. And what I'm going to do is to duplicate this output and plug it to the geometry with RBD detail. And let's assemble this as well. If I go back now, let me see what is. Okay, I'm going to delete this one and I'm going to create a new one. Cool. If I jump back now, I can see my wall has two outputs. The first one, if you dive in, it will be the output number 1. And the second one, it will be the output 2. And this is perfect because if I select this wall, I don't have to compute the RBD interior detail. But if I want to save the high-res geo, I have to file cache the second output of this. So I will replace this cache I have. Let's make some space. And then I'm gonna duplicate this file cache and say this will be proxy wall. And let's save this geometry into the proxy folder. Save this to disk. And this will be the old wall. But I don't need these nodes. And this will be the in-sim wall. Remember, we can visualize the inactive pieces by creating a new plus node to points non-selected. This should be fine, maybe a little bit less. No, it's fine. I'm gonna leave this blast node here, just in case I need later on. And let's do the same with the other. Oh, actually, I have to plug this into the first input. Let's save this again. And now we can see we have 150 points here, 150 points here, but we have high-res geometry here. It looks like we don't have the RBD interior detail. Let me see if this is working. Oh yeah, it's working here. Let's just apply it on the impact area. There's a viewport issue. But yeah, definitely we have the interior detail. I'm gonna do the same exact operation with the doors and the frames, so there's no way you can get lost here, so I'm gonna pause the video and see you in a second. Hello again. So what you can see here is everything properly organized. For example, if I go into the doors subnetwork, I will have the convex decomposition coming from the third input of the RBD interior detail, assemble output 1, and assemble the high-res geo and output 2. So the output 1 is being saved in this proxy folder, unloaded, and same with the high-res file cache. Make sure we always have the same number of packed primitives. And same with the frames. We have the proxy frames and the high-res frames. Now, if every time I make some modifications here, we no longer need to wait until the RBD interior detail is computed. So the other thing I want to fix is the house constraint mix for each loop. As you can see, this is computing because it has a lot of things to do inside this for each. So could be a good idea to just file cache this, and then we don't have to wait until all these operations are done. Let's say, for example, cache constraints mix, and I'm gonna save this into the constraints folder, constraint mix, pgosc. This is just a still frame, so let's save this and load it. Okay. Let's see if we still have the simulation working properly. So I will go into the sim house and I will just press play. Here you go. Perfect. Let's keep going. I think I'm gonna add some hard constraints on the wall because I want some areas to be bent. I think this would be nice, or at least I will have to the control of it. Later on, I will decide whether if I use this or not. So let's go to the house constraint, and this is as easy as copy paste this to the house. So let me see if I agree with these constraints. I think they're fine. Okay. So let's just change the name here. And let's call it in the sim house. Let's make some space. Those are the glue ones. And let's just duplicate it. This time I want the hard wall. I want to visualize these constraints, and here we go. Let me try this time. Remember, we are breaking this constraint using the distance. Let me see if this is working properly. Now, you can see here we have some bending effect. And this looks cool. So let's leave it as it is for now. And let's start calling more and combining with more elements to this geometry. So let's go to the house geo. And remember, it's as easy as to blast the name of the element I want to break. So this time I want to break, for example, the roof. This is going to give me the roof geometry. And I think also it could be a good idea to break all of this. So instead of blasting only the geometry in the door, I'm gonna delete this last node. And I'm gonna break all of this. And along the same line, I'm gonna show you a very cool technique to procedurally have directional wood shapes, directional wood pieces, depending on the axis. These pieces are longer. So let's go ahead and dive in this frames network. I don't need this to be computed, so I'm gonna cancel this booking. Yeah, of course, it's taking much more time because now I'm fetching a lot more geometry, and I want to start from scratch again. So let's delete this, this, this. Okay. Well, before starting with the fracture of this, I would like to explain to you what is my idea. So what I want to do is to to iterate over all of these pieces, and somehow I need to get in which component direction, X, Y, or Z, is this piece longer. And I'm gonna add wood fractures using the same method, and depending on the direction I have. So let's first check if we have an attribute, a name attribute. I'm gonna open this window, name attribute. Okay, so as you can see, we can do this by iterating over all of these pieces. Let's just drop down a for each name primitive. And yeah, I think this piece is perfect. Maybe, yeah, anyone. Let me see. Oh, this, for example, the big one. Actually, let me. No, this one. Okay, gonna start with this one because it's much easier. So if I take a look, I will need to break this piece in the X direction. So somehow I need to add this piece to an X direction group. I'm gonna drop down an attribute wrangle, and let's start by getting the size of this piece. And by this I mean I want to save. I want to store this vector size into some attribute. So the expression you need is get point bbox size of the incoming input. Let's see what we get by casting this vector into the spreadsheet. And as you can see, I'm getting exactly the same values that I have here. Okay. Now let's comment this. And what I need now is to ask which one of these components are bigger. And for example, if this one is the X component of this size is bigger, as you can see, I want to create a group and save this piece into this group. So let's first create a float attribute for each component. So, for example, size X. This is a new variable I'm creating. This will be the size first component. So I'm saying, give me the first component of this vector, which is this one, and save it into a float size X. Now let's do the same with Y and Z. And now I need a conditional. And this simple expression is asking if the maximum value of this vector size, so let's write size, is equal to the size X, let's save, let's create a group called X direction, and this will be 1. What does this mean? It means that it's gonna look over all of these values inside this vector, and if the max value of this vector, which is the first one, is equal to the size X, which is actually the same value, the group X dir is going to be 1, which means that we are going to save this piece into the group X dir. Let's do the same for the other components. Just press Alt and E to open this. And let's just change the components, apply. I don't need to see this size on the spreadsheet. And let's set this to set fracture direction. Let's loop over the old iterations. And we can visualize if this is working by creating 3 color nodes. I can go for the first group, the X, and I'm gonna color it as red. Same with the Y direction, and same with the Z direction. And here we go. So now, if the piece belongs to the x-axis and we want the wood shape fractures, we have to size this down on the x direction. If the piece belongs to the y-axis, we have to size down to the y direction, and so on. And the same with the z. Cool, right? Let's keep going. I'm gonna bypass this and let's split all of these groups. This is called X clear, non-selected. And let me start with this one. So I would love to use these nodes because they are already created. So let's just plug it here. Now it's taking the edges. And I would like to use the target mesh size attribute here if we still have the density. Yeah, we have the density, so let me see. It's a bit low, the density, so maybe I can raise the threshold of the collision geo. No, this was here in the active region. Okay. Let me pump up this value, for example, or maybe the blur 1.5. Let me see what we get. Yeah, this should work. So let's go back to our walls of network. No, sorry, I wasn't in the wall. I was working with the frames. Here we go. Okay. Let me see if I can find this rundle I had, just to avoid writing this again. I think it was here. Okay, so I'm gonna copy this node and I'm gonna paste it here. Perfect. Remember, we have to set this to adaptive. Let's go back to auto update. And here we go. Maybe we can add more resolution to lower density areas. Let me change this to flat shaded. Okay. Actually, if I look closer this piece, yeah, you can see this is not the type of piece I would like to have for fracturing, because the geometry is open. So let's see if we can fix this with a polyfill node before remeshing. So let's add this polyfill, and as you can see now, we have closed geometry. And if you remember, we can check this by using a VDB from Polygon. So this means this geometry is closed. So let's keep going. Right. Let me see. Okay. Okay, this should work. Now remember, all of these pieces belongs to the X direction group. But when we are using a remesh, since we are adding more geometry, we can lose this group at some point. So I have to give to this geometry back the group that it had. So we can simply go to this attribute wrangle and write integer group X direction equals 1. Now I have exactly the same as I had in the nodes before the remesh. Perfect. Now I think I'm gonna add this a little bit of noise. Maybe I can lower the Y direction. Something like this. Okay. And now instead of the Y component, I want to transform this into the X component. BD from polygons. Let's use the density because we have it. So let's set this to point density. Scatter some points here. Voronoi. And transform back again. Let me watch the... here we go. So this is the idea. We are procedurally making these pieces in the way they are longer. And also you can see we have less fracture here because these pieces are far from the impact. Okay. This should be fine, but be aware of something, which is super important. If I copy and paste and I redo this same operation to all the components, there is something is not going to work on the simulation. And this is the name prefix. As you can see, we are taking the name from the subnetwork, but we will have the same values of this name attribute in all of these components. And this will mean that these name attributes will be overwritten on the loop network, and this will cause a lot of problems. So to avoid this, we can simply add something else to this prefix, like, for example, frames X direction. Now I can go ahead and maybe cluster this, recover the position, and I'm gonna press Ctrl and B to maximize this window. I will send this to the merge node. Here we go. Perfect. So let's continue with the y-axis by copying and pasting this. I'm going to delete this one. And this is going to be the y-axis. Let me see the remesh of this. I can keep using the polyfile. Maybe it's useful. Let me see what we get. Okay. Remember, you can fix this frame like I've done in weeks before. I'm not gonna spend time on that again. So let me see if this is working. Yes, let's keep it like this. Now I want to recover our Y direction group. Add some noise again. This should be fine. Transform, but this time to the Y-axis. So I need a reference transform, not from the transform 1, but from the transform 5. Let's wait until the border is done. And let's set this to here. Remember to set this to invert, cluster, and recover the position. Maybe this cluster is too big. And of course, we have to add Y direction here. Okay. Okay. So I'm gonna pause the video again, and I'm gonna do the same with the Z-axis. And also I'm gonna search for what we've done on the last week to fix this frame, okay? See you in a bit. Hello again. So let's quickly summarize what I've done here. The geometry I got was this one. So as we did in the last week, I took the frames and I delete the interior surfaces. I delete by using the normals. I'll extrude this with output back on, and I merge it with everything. So this is what I need. Then this is the same. And on the Y direction, what I did is not to use the polyfill, because otherwise it will fill this this hole here. So let's just I just remesh this, as you can see, using the density attribute, and remember everywhere to add this Y direction to the prefix of these new fractures. Recover the transform, the clusters, which could be even less, and recover the shape. Now it's better. Perfect. And on the same on the Z-axis, this time we have less pieces here, so I deleted now selected the Z direction group, the remesh. Oh, of course, we have to recover the group here, so make sure you set this expression properly. Now you go to the points, everything should be inside this Z direction. Cool, a little bit of noise, and so on and so forth. Then I'll merge all this together, and I use the old method, the method I showed you the last week, promoting the density attribute and using it as to create a new group to add and to redirect the Arbit interior detail using this interior detail group. So now we can see what we got here. This first output will be the proxy geo, and the second one will be the hybrid geo. So let's take a look at it. And as you can see, I don't have any RBD interior detail here, but I have it here next to the impact area. And well, we have the wood fractures pointing to the correct direction. Easy and clean. Perfect. Now let's start with the roof, and this one will be a little bit tricky due to the geometry we have. As I say, this is a library model, so issues like this are always expected. But this is cool, and thanks to this I can show you more good tips and techniques to go over this situation. Before continuing, let me jump back to the frames to network because I think I forgot something. Let me double check all the name attributes created by this border manufacturer. This should be frames x direction, let's see, y direction, and yeah, this should be z direction. So let's quickly fix this, and let's go ahead. This time we don't want wood fractures out of this, so let's just copy and paste the wall subnetwork. Let's set this to manual, and I'm gonna copy and paste this, plug it here. Let's set this to roof, dive inside. Let's go to the first node. Okay, so in a perfect world, these roof tiles would be will have some kind of a name attribute or some kind of geometry connectivity to split one of the other ones. But as you can see, we're not lucky here, and the only way we can split this is by using the name attribute, and all of these pieces goes all together. So this is not used for the log, and we only can fracture this using the old border manufacturer method. So as you can see, if I look closer, we don't have a solid object here, we have a surface. So as we did with the wall, we have to poly-extrude this. We already have this poly-extrude coming from the wall, so let's use it. I'm gonna set this to 0, and I'm gonna set this to point normal, because I want this extrusion to be on the normal direction. And remember, you have to extrude it inside. So let's give some values here. Yeah, this is the direction. Let's set, for example, -0.05, maybe less. Let me check this. Of course, remember to output back. Okay. Maybe a little bit more. Okay. So now we're ready to remesh this. Let's do it by the method we already know. Maybe since this is bigger, this is a bigger geometry, we can raise this value. Let's start with 0.1, and let's see what we get. Let me check this. It's pretty much the same, so let's pump up the resolution. Let's see what we get now. Okay, this is done. It took like 1 minute, 10 seconds to compute this. And maybe this is too much for the border noise, so we can reduce this mesh and maybe create a more odd geometry by using a poly reduce sub. So let's plug it here, and I'm going to keep the 80% of this polygon count. Here we go. This node is super fast and super useful. So let's get over it and give it a little bit of noise, maybe too much. Something like this, maybe. Okay. Let me see. I don't know if we are using the density. Yeah. So a little bit of noise and scatter. Let me add more frequency to it. I'm gonna start with 500 points and let's cluster this. Let's fracture this, sorry. This is taking longer to compute due to the geometry we are connecting to this Bernoulli fracture, not because of the number of these scattered points. But we have to wait. Here we go. Let me see the visualization of this. Okay, I don't want to cluster these pieces this time. And now we have recovered the position. And as you can see, we have the same shape as we had in the first node. So this is perfect. So let's no, I'm not gonna add interior detail to this. So let's just bypass this node because I think they are too thin. But what I need is to convex the composition by name. Let me see. This has a name. What's the matter? Says to found the name, but I do have the name. Let me check this again. I don't know why it's giving an error here. It should work fine. We're not finding the file name. Oh, of course. Look where is this convex decomposition connected. So we have no proxy geometry coming from this node. So we need to use the first one. Here we go. Okay, now let's assemble this. Let's check the number of pieces. 719. Same as here. And then let's just copy paste these nodes here. The first one is the proxy, the second one is the high resolution, and this is the roof. Okay. And roof. Let's say this and this. Perfect. Now we need the new constraints for this new element. So let's go back to house constraint And let me organize this a little bit with network boxes. I can press here, or I can press Shift O. This is going to be the frames. This is going to be the doors. You can look at the name here. And this is going to be the wall. So let's simply duplicate the wall, for example, and change the object merge to sim roof. Okay. Unpack this. Let's check this. Let's set this to roof, and this also to roof. Okay, blue constraints are constraints of the roof, and we have to update these mix constraints. So let's copy and paste the not this, but yeah, or this one, but this is the roof. So I will take this object merge and unpack node. I'm gonna paste it here, and let's give it a different color, like yellow. Merge it here. Okay. Now we have a different color for each set of elements, and this is gonna work as well because it's comparing the two color attributes for each polyline. So let's go to the end of this for each. And we have to compute this every time we change our geometry. But once it's computed, we can cache it. And here we go. Perfect. Let's now go back to the simulation and call the new constraints. You can just let me make some space here. You can just duplicate this and say I want the roof blue constraints, the roof. Let me visualize them. Now, of course, we have to call the roof first as a RBD packed object. So I'm gonna duplicate the wall, call it roof, and let's change this to roof. Here we go. As usual, let's check the collision geometry. Maybe we can shrink this a little bit. Okay, I like it, so let's go on. Oh, not this, this. Let's go on by creating the hard constraints of the roof. I think I'm gonna maximize this with Ctrl V. I'm gonna press L to organize, and let me put these nodes to a better position. These are gonna be the blue constraints, mixed constraints, and hard constraints. Okay. So we have what's this? This is the wall, so let's name it properly. Wall. And now I need the roof hard constraint. So let's copy and paste this here. Name it. And change the path to roof. Let's leave this as it is. Also this. And let me minimize this network by Ctrl V again. And I think this ball, this sphere collision object is too close to the roof, so let's push it away a little bit. I'm gonna go to the collision geo, and let's just move it a little bit here. Okay. Gonna make this longer because I think it's going too fast. Let me check the animation window. Okay, this is now frame 28. Cool. Now, moment of truth. Let's go here. Let me check the glue constraints. Yeah, I think I'm gonna change the propagation rate to 0.5, and I'm gonna make this stronger. Let me check the hard proof constraints. Okay. So let's see what happened now. I'm gonna press play. Oh, just realized we are missing the frames. Where are they? Let's take a look here. Okay, we have to refresh the file cache, I think. So let's save this. And it's going to be, it's going to do the operations again. So I'm gonna pause this for a little second. There you go. Save it, unload it, and this should work like a charm. So let's go back to the simulation, and now we have our frames. Let's hit play again. I like to go to wireframe because I think I found this easy to see what's happening into the geometry and the constraints. So I'm gonna hit play. Of course, if we hadn't saved the frames, we don't have the proper constraints, so we have to update this, because till now we only had the door frames. So let me check this again. Okay, maybe let's give more radius here. All right, and we have to update this because we have changed the geometry. Let's save this. All right, let's go back to the simulation. And these light blue constraints are the ones that we didn't have till now. So let's hit play again. I'm gonna look closer. I'm gonna go frame by frame. Okay, see what's happening here? This is because we have some naming issues. I'm pretty sure some pieces are being overridden by other ones. So since this is happening on the frames, let's go back to the frame geometry and gonna take a look what's going wrong. Let me see. So we have the inside frames. I'm gonna go into the subnetwork and let me see. We should have this Y direction name. Z direction. I'm pretty sure, yes, it could be this RBD cluster that is overwriting the other RBD clusters. Let me see. Take a look at this one. Cluster frames 1. Let me go here. Cluster frames 1. Yeah. So we have to do the same operation as we did with the borderline fracture prefix to the clusters. So let's do it by adding an underscore and y direction. Now we'll have cluster of frames, which is this house geometry, y direction. Let's do the same with the other ones, z direction and x direction. Now you can see how important it is to have this properly named. Let's wait until it computes the convex geometry. Let's save this to disk again. Now we should have cluster on x directions, on y directions, z directions, and the frames. Okay, let's give it a try now. Hope it's working fine. Let's see. Yeah, exactly. Something's wrong with these constraints. Yeah, we have to change as well the... We have to save this again because we have changed the geometry or some attributes of the geometry, in this case the name of the cluster. So again, let's compute this for each loop. And let's go here again. Let me see if we are breaking this properly. Yeah, this should be fine. Hard glue, okay. Okay. Now this debugging could be a little bit annoying and boring, but this is how it goes. And you have to get used to do this kind of operations. So I think it's interesting for you guys to know how I work when I have to face some problems, like now. But I think finally we get what we wanted. Let me go frame by frame. You can see now the glue constraints are starting to disappear. We are starting to break the roof. You can see how the frames are bending here. And this is great because, for example, right now I would like to see only the frames hard constraints. So I know exactly where I have to go, which is here, constrained hard frames. So let me visualize this. I want to see if they are breaking too soon or what. Okay. I'm gonna spend some time tweaking all of this, but of course you can imagine this can take hours for us to have the perfect simulation. So I'm gonna go over some issues, some problems, then I will leave it to you to improve the simulation. Here's another thing I wanted to show you. For example, this constraint, it looks like they're stick together, because they haven't reached the proper distance. But I would like to break it because I think it's unrealistic they stick together. So we can add some other condition besides this distance. We can say, for example, I want this to break. Let me select this, and if I sort this by force, you can see we have huge values in the force attribute. So we should break these constraints, we should delete these primitives using these force attributes as well. So let's blast new. Let's create a new blast. Now I'm gonna say delete the primitives. This force is bigger than, I don't know, let me see. $100. Set this to primitives. Let's hit play again. And we can also grab this node and copy and paste it to other subsolvers. But I recommend you to do one step per simulation. I mean, if you change something, you have to hit play to see what's the difference, to compare it, and then change another parameter, hit play, and so on. Okay. Now you can see how are we breaking everything. And for example, yeah, I don't want these hard constraints to break because this is gonna lead to, this is gonna have all the roof fall down. So for example, again, let's go to the mix constraints and let's set this to bigger value. For example, 0.2. And this is the workflow. Let's hit play again. Take a look closer, see what happens. Let's still breaking, so maybe we can give more value to this. Set this to 0.8. Let me see now. Yeah. Hit play again. Cool. So it looks they are breaking now. But this is not realistic, so let's change this to 0.3 and let's also add another blast node. Tweaking the force bigger than 5,000, for example. Now hit play again. Okay, maybe we can, I think the pieces of the frames are too big, so I can go back and change this by going to frames, and let me, and this is cool too because I only want to have more pieces on the x-axis piece components, so I just have to set this to, for example, 1000. Let's try 1000. I'm gonna give it a last try, and then I'm gonna pause the video, and I'm gonna spend some time looking for a good simulation, and I will show you the parameters I used. But I hope you understand the workflow. It's like trying new values, hitting the play, and debugging until we are happy with our simulation. I'm curious about how is this gonna break. Let me check if we had constraints on this. Yeah, we have. So I think I'm gonna go without constraints. So let's save this again. Save the constraints, because remember that we are changing the geometry. All right, save this, and let's give it a last try. Let me see if I can find a cool bending effect to these frames. Let's set this to way bigger than 100, maybe 10,000 and 0.6, or maybe 0.6. No, this is too much, I think 0.2. Let's set the frames. Yeah, this is breaking too soon, so let's set this to 10,000 and propagation 2.1. No, not this, sorry. The propagation rate. Hit play again. Go frame by frame. Here we go. Are they breaking? Yeah. This is the bending effect I was looking for. As you can see on these roof tiles here. Sorry, these wood tiles. Yeah, this is what I want. Let me see the back of this wall. Okay, good enough. And remember that we are gathering all this here, but now this time we have to import a new element, which is the roof. So I guess this should be the number 5. And if I give it some frames, we can go and transform this. Of course, we have to import the roof, which is roof. See how quickly I am getting the things, because we're staying organized. And this is the magic of Houdini. And yes, I have to go to frames and save the higher res geometry with the interior detail. I didn't save it before, so let's do it now. Let's go back. And here we go. You can see we have interior detail here. But this is cool because we only have interior detail on the impact zone. Not here, not here. Only on the impact area. And this is saving us a lot of polygons. Okay, I'm gonna leave it here. I'm gonna pause the video And I'm going to show you the attributes that give me the most nice evolution, and that should be it. Hello again. So I didn't spend much time until I found something that made me happy. As you can see, it's just a matter of tweaking seeds, values, clusters, constraints, points, one by one, step by step, frame by frame, until you get something beautiful like this. In my case, I can go to the .network, and first thing you will notice is I add more resolution to even more resolution to this X piece component of the frames. Maybe I change, I don't know, I think I change, this is by default, but this was set to 0, 1 to control the spread. I hide the roof because I want to see the frames, but the roof is working fine as well. The glue, I think the glue is pretty much as I left it. So maybe here hard constraints, I think wall, doors, this is by default. Yeah, actually I add more pieces to door. If you see the simulation from behind, you can see now it has more pieces, it has this nice bending. Frames, I set the distance 2.1, the force to more than 2000, nothing fancy. And the roof, I think this is what I had. So yeah, that's pretty much it. But be aware that you are not gonna have the same simulation as I have, because you're not going to have the same geometry, the same constraints. So it's gonna be different for each one of you. I hope you guys enjoyed this week as much as I did, and we are going to add some degrees in the next one, along with the usual production tips and techniques. See you there.